What's up, algebra students? This video is going to go over the Chapter 9 practice test. I can feel your excitement. All right, first question says, solve the equation by completing the square. Okay, so we can only ever complete the square if our equation is a quadratic equation. A quadratic equation is in the form. So a quadratic equation is in the form ax squared plus bx plus c equals 0. So if this is in that form, then we can solve by completing the square. But there's one other issue that has to be addressed. The value of a has to be 1. If it's not 1 to begin with, we're going to have to divide every single term by a in order to get 1, a value of 1 for a. And so you get x squared minus 8x minus 9 equals 0. Okay, now we're ready to complete the square. To complete the square, the next step after getting your a is equal to 1, you want to get the ax squared plus bx is equal to some number, the c, it's negative c, I suppose. If I add 9 to both sides, I get x squared minus 8x equals positive 9. And I left myself space here on purpose, and you'll see why. Now, when we complete the square, remember we're making this binomial into a perfect square trinomial. And the way that we do that is by taking b, the value of b, which is negative 8, dividing it by 2, negative 4, and squaring it, and you get 16. So what we're going to do is we're going to add 16, and by adding 16, we've now completed the square. We've made this into a perfect square. Typically, we would then subtract 16, right? So that you're really adding 0 and you're not changing this expression. But since it's an equation, we've added 16 on the left side. Can't we just add 16 on the right side? The addition property of equality. And if you subtract this 16 on both sides using the subtraction property of equality, you'll see it's positive 16 minus 16. So really, we've just taken that minus 16 and added it over here. So I'm going to rewrite this equation here. This is, I'm going to write this as its square root, which is going to be x plus 4 quantity squared. If you're wondering where I got the 4 from, you just take whatever b was, or I should say x minus 4. It's funny, I did that during the Zoom video too. I don't know why I have that tendency, but okay, I do. X minus 4 quantity squared. And the reason for that is negative 8 divided by 2 is negative 4. So that's how you get that. And if you actually took 2 factors of x minus 4, those 2 binomials, and multiplied them out, you would get x squared minus 8x plus 16. And that's equal to 25 on the right side. Okay, now we can solve this using our kind of square root property of equality. And when you do that, you get 2 equations. One's x minus 4 equals positive 5, and the other is x minus 4 equals negative 5, because negative 5 squared is also 25. If you add 4 to both sides, you get x equals 9, and if you add 4 to both sides, you get x equals negative 1. So those are the solutions to this equation. You could prove that they're the solutions by substituting them back into either the original equation, where a was 2, or the equation that we got after we divided every term by 2. And you'll find that both of those make the equation true. So the big trick here is when you have an equation and you're completing the square, that number you add to complete the square, you can just add it on both sides of the equal sign, and you're good to go because you're using the addition property of equality. Okay, next question. It says determine whether the function has a maximum or minimum, and then find the value. Okay, this is a quadratic function. Why is it a quadratic function instead of a quadratic equation? Because it has y instead of 0. So it has an output. Okay, if a is positive, and in this case a is positive because it's positive 1, then you have a parabola that is right side up or facing upwards. It looks like this. And if it's facing up, right, you have a minimum because the vertex is located at the bottom of it. If a was negative, the parabola would be upside down and there would be a maximum. And when we talk about minimums and maximums, we're talking about the y values, the outputs. So because a is positive, this thing's going to have a minimum. Function has a minimum because the value of a is not negative, and the value of a is positive. Cool. Okay, so we know that it has a minimum. Now we have to find the value. There are lots of ways to do this. One of the ways, let's just think about this from a chapter 7 perspective, and then or a chapter 8 perspective, sorry, and then a chapter 9 perspective. Our chapter 8 perspective is to use the axis of symmetry, x equals negative b over 2a. Now, that will tell us the x value of the vertex, but that's not the minimum, right? Because the minimum is the y value. So we're going to have to find what that value is, substitute it back into the original function, and then we get the output. That's a chapter 8 perspective. It works perfectly well. I have no problem with it at all. The chapter 9 perspective would be, well, if we want the vertex, if we want the location of the vertex, why don't we just convert standard form to vertex form? And you do that by completing the square. So y equals x squared minus 6x. Okay, now I'm going to add something and I'm going to subtract something. And then there's already a -4 waiting for me at the end, right? The -4 is there. The ax squared or 1x squared plus bx, this is the thing we're going to complete the square on. The -4 is not part of it. So we just leave it off to the side. What number am I going to add and subtract? Well, you take b, you divide it by 2, -3, you square it, you get 9. So we're going to add and subtract 9. So we're really adding 0. This is now a perfect square. Now you might be saying, well, why on the first question we add 9 on both sides, but on this question it's 9 minus 9? I could have added this 9 on the left side, but we're going to vertex form where y stays by itself. So there's no reason for me to put a 9 over there, because then I just have to move it back over at the end anyway. Okay, what is the square root of x squared minus 6x plus 9? It's x minus 3, right? Because you take b, divide it by 2, you get 3. And then, of course, that's squared. If you had two factors of the quantity x minus 3 and you multiplied them together, their product would be x squared minus 6x plus 9. Now, minus 9 minus 4, that's -13. Where is the vertex in this standard form? Here's standard form. Sorry, this is vertex form. Where's the vertex in vertex form? The vertex is always located at h comma k. It was the same as it was on a absolute value function. So it's h comma k. Sorry, that comma looked like a 2. Okay, h comma k. So where is that on this one? The vertex is at +3 inside opposite land, right? So that's translation right 3, down 13. And since we're trying to find the minimum, the y value, the minimum's equal to -13. Cool, that's the end of part 1. I'm going to come back for part 2. I'll be back in just a moment.